Okay, let's do some binomial expansion. And that is, shocker here, expanding a binomial. You have something with two terms and you want to expand it out very quickly. Well, let's look at some of the easy ones. Anything to the 0th power is 1. If I said, what is a plus b to the first? You would say that's a plus b. If I say square it out, I certainly hope you would not just say a squared plus b squared. You would think about foiling and you would square it out to get that. Now, if I ask you for a plus b cubed, I'm not going to take the time to do it, but you would have to take this answer, multiply it by a plus b, get in a system, multiply the a through, multiply the b through, add like terms, and you would, if you don't believe me, you can do it on your own, you would get something like this. So you'd have that. All right. Well, let's see here. What do I notice? Let's go down to this one because I think this one kind of, you can see it a little bit better. Now, I can talk about A and B, but I just want to make sure that I'm doing it with something you could use in general. What if the letters aren't A and B? So I'm just going to call this the first thing and this one the second thing. What pattern do you notice in the exponents? Well, the exponents on the A's, they start with 3, they go 3, 2, 1, and 0. So the powers of the first, they decrease from the power down to 0. Okay. Now, what about the second, the B's? Well, I didn't write it, but there's really a B to the 0 here because we know that anything to the 0 is 1. So I just don't write it. So the B's go 0, 1, 2, and 3. So the powers of the second increase from 0 all the way up to the power. And something else I'd like you to note, especially, I know you don't have to write the ones, but if you look in each term, do you see how all of them add up to 3, even if I wrote the A to the 0? Do you see how all those add up to the power? So that's kind of a nice thing to know as well. These guys add up to the power, or to n. Okay, now let's look at something else. Let's write just the coefficients and describe the pattern. In other words, if I took out all the A's and the B's and the pluses, what would that look like? It would kind of make a triangle shape. So if I have 1 here, 1, 1, 1, 1, 1. Now take out the A's, the B's, and the pluses, and what do I have? I'm going to start over here. I would have 1 and 1, like that. Then I'd have 1, 2, and 1. And I'd have 1, 3, 3, and 1. That's interesting. It says complete the table through n equals 6. I'm going to kind of go down to here. It's like, well, gosh, I don't know. Well, what do you notice about the first and the last? Okay. In other words, when this is 3, do you see how I have 3's there? Well, the first and the last are always 1. Every single time I have 1 and 1. So what do you think the second term is? Or the second number here, 4 and 4. What about that middle one? Well, what's really cool, I really could have started this triangle with just 3 1s. Do you see if I add 1 and 1, I get 2? And when I go to the next row, if I add that and I add that, I get 3. The next row, if I add, and add, well, now I can get that middle number. That would be a 6. Let's see if we can get the next row. It says go through n being 6. Because notice, this is when n is 0, n is 1, n is 2, n, not 2, n is 3, N is 4. And let's do 5 and 6. See if we can get those in there. So again, let's do some adding. I'm going to kind of move those red numbers out. 1, let's add 5, 10, 10, 5, and 1. And finally, 1, 6, 15, 20, 15, 6, and 1. And that, my friends, is called Pascal's triangle. A great mathematician realized that, and got the triangle named after himself when he published. So pretty cool. Now you're like, okay, that's great and all. That's cool, but how does that help me? Well, let's do number 1. It says, use these patterns to expand the following binomial. I certainly don't want to multiply a plus b out 5 times. That's going to take me forever. You can actually do it very, very quickly. And I know this one is easy, but I'm going to do the steps so when I get to the next 2 harder ones, you see that I'm doing the exact same thing. Here's how I want you to start. I want you to start by putting a blank. This is my first, this is my second. Okay? The first one starts at your power and goes down. Now in this one, I'll go ahead and put the 0 in there. From here on out, I won't even bother writing that. But just to, again, show you how they add up to the 5. So the A powers are going down. The B powers are going up. And if you go, well, I already know what the blanks are. That's great as well. I'm just showing you the method. Now, let's see. I forget to write the 0 sometimes because I'm so used to not doing it. A to the 0, B to the 5th. So that's what I have. Now, here's how we can use this triangle. It's the 5th row. So my blanks, the first and the last are always 1. The second and the second last are always the power, in this case 5. And these 2 middle ones, I've already done the chart. So I have 10 and 10. And you go, well, do I have to memorize this chart? Well, I'll be honest. I mean, I would think you could at least start here and then developing those 2, 3 wouldn't be that bad. So for now, if it's a low number, then yeah, you could kind of develop it, or doing your homework, you'll probably have them memorized anyway. Now let's write the final answer, because I don't want you to put b to the 0. And I don't care if you put to the first power. It's not bad if you do. I'm not going to write that. But look how quickly I can expand that out without having to multiply. So this is my final answer that I did very quickly using binomial expansion. Okay? All right, so let's do a little more difficult one. Now, a more difficult one is, all right, I got this. Well, here's the deal. First of all, with the minus, I'm telling you it's best to tack that minus with that second one. So my first is going to be 2a, and my second is going to be a -3. Now, I want you to look as I'm doing, and I'd rather you just watch for a second and then kind of stop the video and write down. I want you to see that what I'm doing is the exact same thing as I did on that last example. It's just that my first is parentheses 2a. If it's more than one letter, parentheses are a very, very big deal. I'm not going to do to the 0 because I know it's going to go away anyway. So I'm putting in my blanks. Those are going down. The 2a's are going down, and the -3 powers are going up. And I would have this. That's where I'm at. Perfect. Then what's my next step? I fill in my blanks. If I fill in my blanks, I know I have 1 and 1. I know I have 5 and 5, and you probably already remember that that's 10 and 10. Now, the simplifying on this one is the harder part. And I'm not going to get on a calculator for this because I think I'm going to write down what you would type in, but I don't think I have to show you how to type in multiplication. So when I clean up, let's look at each term. This first term, you're going to clean up all your numbers together. So I have a 1 times 2 to the 5th. Well, 2 to the 5th, you probably know that in your head. That's a 32, and then you have a to the 5th. Now let's look at this second one. In this second one, let's talk about what you have. What should you actually type in your calculator? You have a 5 times 2 to the 4th times a -3 to the 1st. That's what you need to type in. Now, the parentheses around the 2 isn't that important. You don't have to type those parentheses, but you certainly need to type the parentheses around the -3. And if you type that in, you should get -240, a to the 4th. Let's look at the next term. What would you type in? All your numbers. You've got 10 times 2 to the 3rd times -3 squared. That one I can do in my head. 9 times 8, 72, times 10. So that's a positive 720, a to the 3rd. Next term, 10 times 2 squared times -3 to the 3rd. I would get -1080, a squared. And I hope that you can see those last 2 terms, what I would type in to get this final answer. Now, you might be saying, well, gosh, I realize that when you're doing a minus, the signs just alternate, positive, negative, positive, negative, positive, negative. So I'll just forget that negative and then just kind of alternate my signs at the end. If the question asks you to expand, that really is a valid thought. However, I also know some other types of questions we're going to do a little bit, and where we're going to isolate and like specifically only go for one term. So in that case, you really, because you don't know which term that is. So I would suggest, that's why I like doing that negative, because I think it would save you on those questions. So I'm just going to do all the problems the same way. So what I'd like for you to do is stop the video, and I'd like for you to try number 3 on your own and come back, start it back up when you are done. So let's do this one. I'm going to put a plus minus. So I'm going to start with my blanks. I'm going to have x squared as my first. It's going to start with 4. He's going to go down. And -5y is going to go up. -5y cubed. And I would have that. Again, the x squared is 4, 3, 2, 1, 0. The -5y, 0, 1, 2, 3, 4. Perfect. Now let's do your numbers. The first and the last, always 1. The second and second to last, always 4. And I bet you remember that last one. And that's a 6. So let's clean it up. I have to remember some exponent rules. Power to a power, I multiply. So that first term is x to the 8th. Let's get this next term. Let's combine the numbers. I have a 4 and a -5 to the 1st. I don't need a calculator. Let's do that in my noggin. I would get -20 x to the 6th times y. Next term, numbers, I would have a -5 squared. -5 squared, that's 25 times 6. That is a positive 150 x to the 4th y squared. I'd probably jump on a calculator here, but I'm not going to. Again, I'd have -5 cubed times 4. So that's, you could probably do that one. -500 x squared y cubed. And then negative 5 to the fourth would be positive 625 y to the fourth. So did you get there? Were you able to expand that all out? Hope so. Hope so. Now you might be going, well, gosh, okay, that sounds pretty good. But let's look. What if you were doing a problem where you needed to know the 15th row? Now I was pretty good with going through 6, but seriously, you want me to go to the 15th row? You're crazy. Well, the good news is there's another way of actually doing these values. But before I kind of talk about that, I have to talk about some things in the calculator. First of which, if you're in stat, you probably know all these things, but for people that aren't in stat, we need to kind of talk for just a second, a very, very surface level conversation about it. First of all is a factorial. If I was doing number 4, it's not that I'm, super excited about that 6, like, ooh, 6. No, that's 6 factorial. That factorial means something in math. It means 6 times 5 times 4 times 3 times 2 times 1. And that is my answer. So the formula is really you do n times n minus 1 times n minus 2 all the way down to multiplying by 1. Okay. 0 factorial is by definition 1, just FYI. Now, the good thing is I know you could type in 6 times 5 times 4, but even better, let me get on my calculator now and show you on the calculator something cool, is that, let me just go to my home screen here. And if I type in 6 math PRB and go to number 4, it puts then that exclamation and I can get 720. So the calculator actually does that for you. I don't know what that little advertisement is there, but anyway. All right, combinations. If you're doing a combination of out of 5 things, choose 3 to be on a committee or whatever the case may be, there is a formula for that as well. Again, you stat people would be like, oh yes, we did these over and over. It is n factorial over r factorial, and then you have that in the bottom as well. Now, let me be honest, is that there is a calculator button for that. So you're like, do I even need to know the formula? For the purposes of our course, no. You don't necessarily need to know the formula, because I could just type in, if I was doing 8 combination of 3, I type in the 8, I go to math, again, back over to the probability, so I can arrow over, and there it is, number 3. Sorry, these new calculators do it this way. Old calculators, you typed in that way. So let me start over. I'm not sure what your 84 does. So let me be clear. I think on the 84, if you have an old system, I think you have to type it in. Unfortunately, I can't do it as well because I can't get the exact 84. So on your calculator, you actually have to type in, I'm not going to show it because it's not the exact same. You type in the 8, you hit the NCR button by under math prob, and then you type in the 3, and then it gives you the value. If you have a newer calculator, I'm going to do the math. I'm going to get the NCR. Oh, goodness gracious. I'm going to do the math. I'll get it together. Prob, and I can type it in where it looks exactly like the page. So it kind of depends on the kind of calculator you have. Again, with our 84s on test days, you're going to have to type it in like that and give you 56. Now, for just a second, I'm going to kind of focus on just so you know, because some of the ones on the homework ask you to do them without a calculator, and that's where you use the formula. Really, that's kind of maybe for SAT or ACT purposes. If I were doing this without a calculator, I would get, using the formula, 8 factorial over subtract, and do the bottom. So you see how I have 8 factorial, that's n. R is 3, so 3 factorial, and then 5, subtract 5 factorial. These two numbers will always add up to your power. Now you're like, well, how am I supposed to do that without a calculator? The smartest thing is to write this guy until the bigger number on the bottom, like that, so that you can cancel it out. So I'm like, ooh, boom, boom. Now 3 factorial I can do in my head. 3 factorial is 3 times 2 times 1, which is, of course, 6. That cancels, and I am good to go. So my answer is 56. Now use your calculator just to see something. I want you to first practice, and I'm not going to do all these. You can stop. Do you see if you do 6, choose 0, 6, choose 1, 6, choose 2, 3, 4, 5, 6, you are going to be just so shocked at what you get. You get these numbers. Well, gosh, let me go back up here. Do you see? Looky here. It's the same as Pascal's triangle. So if you wanted to get these numbers, I think it's a lot slower if you have to type in each one. But I technically could do the combination on each of those. Now, what that's good for, you're like, well, you just said done to do it. Well, let's go to do this example. Find the 6th term of something to 15th. I am not going to want to go to the 15th row. Okay, here's what I want to do. If they're asking me for a specific term, people, it's like I'm isolating. I just randomly circled this one. I'm isolating one term and going for that. Do you realize that each term has a blank? It would have an x to some power and a 4 to some power. Well, now how do you get the powers? Let me go back up here, and I'm scrolling a lot, so hopefully not making you sick there. But look at this. Let me do it on this one where I wrote the zeros. Do you see, and look where I'm pointing, do you see that this is the first term? This is the second term. This is the third term. This is the fourth term. This is the fifth term. And this is the sixth term. What did I just realize? When I said the term, the exponent on that second thing is 1 less. So if I ask for the 6th term of that expansion, I know that that number is going to be 5. This exponent is 1 less than the term number. Now, the good news is if I know that's 5, what do you know about this one and this one? They add up to your power. So if that one is a 5, then this guy is a 10. Now you're like, well, how do I know what goes here? Well, here's the deal. It's always power, choose the exponent on the second. So this one is always your power. This one is the exponent on the second thing. So see how that's 5? And that's 5 as well. All right, so to clean this up, I have 15 choose 5. And then times 4 to the 5th because I want it all cleaned up. On your calculator, hit 15, math prob 5, and you'll get it. On mine, I do it a little bit differently. I'm going to go over to math prob, and I'm going to type in 15 there and 5 there. Now, I do it in one fell swoop. I just kind of go times 4 to the 5th. I don't get each individual number. I just do it all as one. I hit enter. And so my final answer is 3075072 x to the 10th. So this would be my final answer. All right, last one. It says find the coefficient Coefficient means number only. Of the term containing x to the 12th. Notice this one does not say a term number. When it doesn't say a term number, you're just going to be smart and use your little noggins. First of all, remember, this is why it's important to put that negative with the second one. And there's the bell to go home. But I'll stay and finish the video. So here we go. I put the negative with that second one. Now, if it says the term containing x to the 12th, well, guys, if it contains x to the 12th, that means in the simplified version. That means this one would have to be a 6. So when I simplify, I get x to the 12th. If that one is 6, this one has to be 3 because they have to add to 9. How do I get the number in front? It's always power, choose, exponent on the second thing. Now in our calculator, we're going to do 9 choose 3. And then I'm going to have to do times. Please know when it says coefficient, it doesn't mean just this blank. It means when you simplify everything. Times -3 to the 3rd. You know what? I know that in my head. So I'm just going to do times -27. And so my answer, it just said coefficient. So I'm just going to write the number part. I get that right there. And there you have it. So that's your binomial expansion.